Ricardo Calix from Louisiana State University is going to tell us about Affect Corpus 2.0, an extension of a corpus for actor level emotion magnitude detection. And he's actually graduating this year. Is that correct? Hopefully. Should we talk to your advisor? No. So he'll be on the job market soon. So if you're interested in his work, please, and have open positions, please contact him after the talk. Let's go ahead.
All right. Thanks everyone for staying. This is the last talk. I'm sure you're all tired. This talk is a little bit different. This corpus that we developed is more general to multimedia applications, we think. Affect is emotion, for those of you that aren't familiar. So it's basically 2.0 also, so it's an extension of an existing corpus. My work is in automatic emotion detection from language, text and speech for multimedia applications. So I'm interested in text-to-scene processing. This is a work by myself and Dr. Gerald Knapp at LSU. Okay, so the objectives, currently there's interest in emotion detection systems and prediction, so using machine learning to detect emotion, to use for advertisements a lot, so there's a lot of use of information, whether it's speech or text. So for instance, if you have things like blogs, you have Twitter, etc., and advertisements, companies may want to text mine your information and determine if you like something, a product. The same applies for speech. For instance, we're all familiar with just calling in over the phone and getting a machine, trying to answer our questions, and then getting frustrated when the machine doesn't understand us. So there's this idea of human-computer interaction, and now this word of social media has become very important because of Facebook. We all know that. So there's a lot of emotional content there. There's a lot of emotion and behavior that's that we as humans have, and we need ways to capture that, right? So that's what I'm going to talk about. So we need resources that we can use to develop automatic systems that can train and test for emotion detection. So we've done some work. We found this after looking for different type of corpora. We found this corpus at the University of Illinois at Urbana-Champaign, the Affect corpus, and we did some analysis. This corpus annotated emotions at the sentence level. So we used that information, but in the end, we concluded that there were some problems with it, at least for the applications that we wanted to develop. We wanted to have some more information on who the people are in these. This, by the way, is a children's story corpus, so there are issues of generalizing it to bigger applications, and I'll just mention some of that later. So basically, we need, for our purposes, first of all, we need to know where the actors are in the story. And this is, we can say there's either text or speech, because we can also have MP3 files of audio of a story, right? So we want to find the actors. We want to know where they're present throughout the story. And also, we're not just interested in the class, what emotion do they experience, but what magnitude of it. And I'll show you why this would be important as well for our vision of what we want to do. So what we did is we performed these annotations in the corpus. We identified all the actors per story. Then once we've identified the actors in the story, we select them, we assign magnitude. So that's basically where humans come in. They use a tool that we've implemented, and they identify an actor and they say, this actor is happy and I think the magnitude is this. Okay, and there's also issues of, annotation of emotions is very subjective. So we did some inter-annotator agreement just to get a measure of that. So we also provided additional things for the corpus, like for the text, the transcripts of the speech signal. We have sentence parsers, etc., just so that we can help other developers, so that they don't have to worry about that. So there's provided some XML markup in there that has additional annotations that can be used by doing queries, so sort of like a database. For the speech annotation, the UIUC corpus did not include speech annotation, but we found a resource, LibriVox, that had several of the stories that we needed already recorded. We spent some time to compare the text to the speech audio to make sure that they matched, and then we included them in the corpus. For those that we didn't have, we have a professional reader that has been reading the stories. Okay, so the idea is that we'll have the text, but also there is additional information in just a speech signal in terms of intonation. And so that's what we really want to capture. We're assuming that we're at the point where a system an ASR would be able to take the audio and convert it into text in some way. Okay, and then as far as sentence boundaries and alignment, we use Pratt. This is an available tool just to indicate we annotated this manually as well, although this can be done automatically as well, but we wanted to make sure that this aligned with UIUC's initial class annotations and also with our magnitude annotations. And like I said, we present some inter-annotator agreements of a subset of the corpus just to get some metric. The inter-annotator agreement gives us like a boundary, a minimum boundary of the accuracy that a machine learning system could get. We just implemented some very simple application, but it's important though, although it's simple in a little program, this makes sure that there is some system. The methodology that we use to annotate the stories is systematic. So here you can see, I believe this, yeah. So I don't know if that points, but you can see basically it's divided into two areas. One area is where the story is, and we're reading through the sentences line by line. We're keeping track of the sentence number. We're adding the actors to the right, and then the top area is really like the scene. So we simplify the problem by saying, imagine that this is a stage. We're going to get some actors to play out these roles. So that's the logic that we give to our annotators. So then they select the actors that are present in the story. For the most part, we try to get those initially, but the annotators do have the freedom to add new actors if they think that someone is. And this is also subjective. So we provide this information, and there's different ways that we can process the data. As you can see, each one of the boxes in this scene area is an actor, and then we have scroll bars where we can track the magnitude. And the magnitudes are, although they're numbers from 0 to 1, we try to divide them into 4 categories. We provide a small picture there just so that people know, okay, this is happier than this, and etc. And also they can assign several emotions at the same time. So some statistics of the corpus. There are 176 stories by 3 authors. This is what UIUC collected. They have about 15,302 sentences. Additional work we did is we calculated the number of NPs. NPs are important from an NLP point of view because they usually contain the actors. So there are different ways that we can get this dependency parses and syntactic parses, etc. But these 45,000 NPs identify either the actors or other objects in the story, which will be useful for what we want to do, which is text to scene, generate some graphics, and do things like that. All right, as far as neutral classes, most of the sentences in a story don't have emotion. Instead, they're just assertion. So in that case, we're talking about neutral sentences. For that, we just represented if all emotion magnitudes are 0, then it's neutral. For the speech characteristics, so far we have about 129 speech files, but we've only been able to annotate 89. We're still ongoing, so we still plan to add more. And you can see here we have 59 for Grimm's. These are the authors, Grimm's, Potter, H.C. Anderson. And also we have a lot of different speakers. So usually in data sets, like there's a very famous one, German data set, which has, it uses not that many speakers. So the idea is to try to capture the variability of language by using many speakers. And here, since we're using LibriVox, most of the stories that we found were from different speakers, native English speakers for the most part. All right, so the structure of the corpus, we've posted it. It's available online. So basically, it's divided into 4 sections. We have the UIUC section, which is the original annotation and is available from UIUC as well. We have an XML markup, which just includes, for each story, an XML file. And then we have the emotion magnitudes, which includes the actors and the emotion vectors that we call them, where we keep track per sentence of the magnitudes. And finally, of course, there's the speech section, which is just a text grid. The stories are separate, but you can download them for free from our website or MMSys. They're about 1 gig in size. The format is MP3. So this is what an emotion vector looks like. So here we have the sentence. We tried every single annotation that we made, we tried to make it independent. All right, so in that sense, we always try to provide the sentence with the annotation, although it increases the size just because it's easier to understand and it's easier to use it independently instead of having to align this to the original stories. Okay, as you can see there, we have the sentence number as the first feature, then the actor name. The actor name is really the ID, if you want to think of it that way, because initially we just made sure, we told the annotators, select one actor or use the actors already pre-selected, and make sure you always use that actor. So it's basically where you saw the scene, they would grab the actor, put him on scene, annotate him. If they thought they left the scene, they would just remove him. So it's the idea is that we're always keeping track of that number. And we have the magnitudes plus a presence vector, which keeps track of the actor through the story. And that's the last one feature. So you can see Jemima became much alarmed. Jemima Puddle Duck is there. Now, one of the things that's nice about this is with these vectors, we can, if you look at this graph, we have on the x-axis, we have the sentence position throughout the story. So it's got 100 sentences, and then the magnitudes on the y-axis. So we can keep track of everything that's happening to that one actor through the story without reading it. And this is what we want to do. We want to map this to some application. For instance, if you're reading a story, maybe you want to add music to it. And by adding music, you want to add music that has to do with that emotion. So here you can see, for instance, around sentence 20, they were happy. Then something happened between 60 and 80 that made them really afraid, but finally everything's resolved. And it's happy again. So you can see that the music could be tuned to this. So, and that's what I just said. We performed some inter-annotator agreement metrics just to make sure that there is some boundary here. So we performed it on 19 sentences. You can see. I'll just say something really quick about this. The annotation is, it's not categorical, so we had to convert it to categorical to have some way of comparison. And you can see the results between assignments that included neutral and assignments that didn't include neutral. The scores are low, but that just reflects the fact that annotating emotion is a very difficult problem. If you have any questions, I can talk about this later, but I'm short on time. So I just have a few more slides. So the applications of this, speech, text-to-scene processing, that's specifically what I'm trying to do. But you can tune text to speech, and there's social media mining in text and speech as well, anti-terrorism. Now, as far as what we're trying to do with the graphics, the regression, the magnitudes that we have, we're trying to create a model that can predict through regression some magnitude, and then we can map those to facial expressions. And that way we can use morph targets to go from neutral to happy and in between. And then once we have the actors, create a scene. So in conclusion, just to wrap up, we've annotated this corpus. We have emotion magnitudes, actor detection, speech, perform inter-annotator metrics, and we believe that this could be useful for multimedia applications. Future works, just speech extension. I've mentioned this, and that's it. Thank you.